All right, we'll do 7, 8, and 9 here together. All of them are based on information contained in the graph of f prime. Do notice that it's an f prime graph. So for number 7, they ask us the tangent line at 3. So the two things I need are f of 3 and f prime of 3. If I know those two things, then I know the equation of the tangent line. F prime of 3 from the graph is just 2. And so my equation is going to be y minus the y coordinate equals the slope times x minus the x coordinate. Looking through my answers, C is your best option for number 7. Number 8 asks, how many points of inflection does the graph of f have? So points of inflection are when the second derivative changes sign. And that's the key thing. I'm looking for a change in sign. When I'm looking at the graph of f prime, f double prime is the slope of f prime. So I'm basically looking for when is this slope changing sign. And if I count the points, 1, 2, 3, 4, 5, 6, there are 6 of those. So my best answer for 8 is E. All right, let's also jump on, look at number 9. Number 9 says, at what value is there an absolute minimum? So I want to do an analysis of the first derivative. My critical numbers are 4 and 6. At both of those points, the derivative is 0. My intervals are positive, positive, and negative. And so my graph of f is increasing, flat, then increasing, and then decreasing. So I can kind of see the behavior, the shape of this graph. There are no relative minimums, so that means my absolute minimum has to be either the right endpoint or the left endpoint. And it actually could be either, but when I look at the graph and I think about the change in f, remember, change in f, we'll do f. Let's write it this way. F of 6 minus f of 0 is going to be the integral of f prime. In other words, the area here, all of this area, is basically how much the graph is going to go up. And this area from 6 to 8 is how much the graph's going to go down. So it's pretty clear that the integral from 0 to 6 is greater than the integral from 6 to 8. Which means that I'm going to go up much more than I'm going down. That makes the left endpoint our absolute minimum, and so 0 is our answer.